Okay. Good morning, everyone. In today class, we will discuss about one of the main type of parametric statistics, which we call one sample t-test. Okay. In this class, we will discuss about the theory, like what is the one sample t-test and how can we do while using SPSS. So we will cover some a bit of theory, little bit of basic information, and how can we using how can we command it by using the SPSS. Okay, so now coming toward the first slides of the presentation. This is like the general outline, like the general overview of the statistical tests and one sample t-test, independent sample t-test, peer t-test, and practical demonstration using SPSS. Actually, this is a series that I make for the parametric statistics, but in this video, I will just cover the one sample t-test. So for the other independent sample, peer t-test, and ANOVA, you can come to the to my channel. On the playlist, you will find these videos. Now, when to do the statistical test? Okay, like this, if our main aims or our hypothesis is according to these six criteria, anyone, so we can use the statistical test. For example, difference in the sample or a population or a group of population means. Okay, if you want to to measure or see the difference between the sample and a population means. Okay, number two is difference in two sample means. So if we have two samples, we want to measure what is the difference between these two means, so we can also use the statistical test. The third one is that if we have several population means, we want to compare between them, so we also use the statistical test. And the fourth one is like difference and proportion between the sample and the population. So if we don't have a mean, but we have the data in the frequency and percentages, so we can also use the statistical tests. Okay, difference in the proportion between two independent sample, and the sixth one is significance of association between two variables. Like we want to associate between two variables. Okay, we then still use statistical tests. Okay, in the statistical test, we have two type of main tests. One is called parametric and other is called non-parametric. So in the parametric part, we will discuss a little bit about it. In the parametric, there is three main group types. Number one is called t-test. Number two is called ANOVA, and the third one is called Pearson correlations. Okay, in the t-test, for example, our hypothesis or our is like or our study design is like of one sample. So we use one sample t-test. But if we have two sample, and the two sample we have then two criteria. One is whether these two sample is dependent or these two sample is not non-dependent. If it is dependent, so we use peer sample t-test. If these two are not dependent, so we use independent sample t-test, which is, or the I will also make a video on these two and also on ANOVA. So please subscribe the channel, and you will find them on the playlist of this video. Okay, now come back. And the second is like ANOVA. At ANOVA, we have one-way ANOVA, one-way repeated ANOVA, two-way ANOVA, and two-way mixed ANOVA. Okay, and the Pearson correlations also. This is the type of parametric statistics. Okay, parametric test. Sorry. Now, parametric statistics, if we are using any of them, any of the above tests, like the parametric tests, so we have to follow these four assumptions. These four assumptions must be fulfilled. Okay. Number one, the data must be qualitative. Okay. If our data is quantitative, so we cannot apply parametric tests. Okay. The second one is if we have the data is quantitative, then which type of data is actually it is quantitative. And the quantitative we have sub four category. So if the data is interval or ratio scale, in this case, only we apply parametric statistics. If it is not interval or neither ratio, like it is not, so it is not eligible for the parametric statistics. The second one is data should be normally distributed. Okay, so how can we do whether the data is normally, like the first two, we can just see to the data and we can we can just identify whether the data is quantitative and the data is continuous ratio and interval. So we just do and see with the data, so it's okay. But the normality of the data cannot be assessed just by seeing. It must be it must be assessed, or it must be confirmed by some statistical tests. Okay, so I also make one video on this, how to check normality of the data, on which is present on the playlist, so we can find it there. Okay, the fourth one is equality of variance. If we have two groups, so in both groups, the variance should be equally assumed. We call it homogeneity of variance. So homogeneity of variance should also be assumed. I also covered this part and the normality videos. Okay, you can see it from there. So now come to the one sample t-test, which is the main topic of our presentation. So one sample t-test is actually, it is used to compare the mean of a sample to the mean of a population. Okay, for example, if we have, this is like for example, a sample mean, and this is like the population mean. So our hypothesis, and this if our research hypothesis is, we want to check whether the sample mean is equal to the population mean or not. Okay, and short version, for example, if you have one value and you want to compare this with some constant value, so in this case, you will use one sample t-test. Okay, like you have one sample and one is the sample data and one is the broader, like the constant value. So you want to compare the constant value with your result, with your results. Okay, so in that case, you use one sample t-test. Okay, so make a statistical decision as to whether or not the sample mean is different from the population. So in this case, you will make a hypothesis that the sample mean is different from the population mean, or the sample mean is equal to the population mean. So now come to the assumption of the one sample t-test. And statistic, there is always assumption for every test. So if it passes this assumption, then in that case only you will apply this test to your data set. Okay. The first assumption is the sample are randomly selected. As I thought, like we want to compare the sample with the population. So the sample which is chosen from this population, it should be randomly selected. Okay. The random selection, they have different type of methods. So you can study them. It is because you can study them. Okay. So it is like it should be randomly selected. The second one is the data is quantitative. Okay, this is the main assumption. It is for every statistical test. It must be quantitative. The third one is variable follow normal distribution. Okay, so it should be normal distributed. The variable you want to test must be normally distributed. Okay, the fourth one is sample variance from both group are similar. Okay, if we have the sample and we have the population, so the variance between this group must be similar. And the fifth one is the sample is small, mostly less than 3. But nowadays, this was actually assumption when there is no SPSS software. So, but now due to luckily we have the SPSS software, and SPSS do everything for us. So nowadays, like this first 3 assumption is compulsory. You have to confirm this before you applying the one sample t-test. But due to SPSS, if the variance is not assumed, homogeneity of variance is not assumed, you can still apply one sample t-test. And if the sample size is larger than 30, for example, 40, 50, but not too much, not too large, like for example, 100 or more than 100, then if it is little above than 30, you can still apply one sample t-test. Like this 2 is optional if you are using SPSS for analysis, but this 3 is compulsory. But if you are using the formula for one sample t-test, then all of these assumptions must be fulfilled. Okay, before applying the analyzing your data by one sample t-test. Okay. Now let's come to the examples. Okay, like for example, if we have the example, does the mean age of the testing sample equal to the mean age of the elderly or not? Like this will be your hypothesis for the research, or from the data that I will explain in the practical sessions, is from the data the average age of the sample is equal to 45 year or not. Okay, so like this is our question. We will do it in our practical class. Okay, you have to keep this 45 year in mind. Okay. Now our hypothesis is that the population mean is equal to, the sample mean is equal to 45, sample mean is not equal to 45. Okay, the population mean is equal to 45, population is not equal to 45. Okay, now this is the command when you do the SPSS test and the by the this one sample details by the SPSS. So you have to come to the analyze, then compare mean, one sample t-test, select this, and select the age and test variable box, and set the test value is 45. Okay, so now come toward the practical part of this presentation. This is like the SPSS for, okay, this value. This is our SPSS data. Okay, and this we have this is the data. Okay, this is all our data. Okay, we have 144 participants. Okay, of the sample size 144. Okay, now as I discussed earlier, we have to first check whether the data is For example, if you want to compare, our question is age, okay, come to age and look to the data. It is like scale, so it is ratio scale. It is like, it is the quantitative data, and it is past the first assumption. The second one is it must be like the continuous data, and it should be like the ratio scale, okay. So it is like past the second assumption. Now the third assumption is the data should be like what we call, the data should be uh, the data should be normally distributed, okay. To check the normality of the data, so we come to here to the okay, come to analyze. We actually want to check the normality of the data, whether the data is normally skewed or not. Come to analyze, then explore, okay, explore. And then as I will reset this again. For example, if this is age, the age, this we want to check the normality, the one sample t test, okay. So dependent list, come to the statistics. So we have to just check the descriptive, okay, continue. Then we have to come to the plots. So we need statistic normality test with plots, okay. So continue. Now, okay. Now SPSS will automatically analyze the data for you, and this is your, like, this is the SPSS test that we as I discussed in my previous video. Like, if you want to check whether the data is normally distributed or not, we come to the descriptive and we compare the value of mean with median. So let's see, the mean value is 58.20 and the median is 57.00. So it is somehow near. So when the value is same or near, so it means the data is normally distributed. And the second assumption is like you to compare the mean with 5% trim mean. So it is 58.20, 58.03. So it also passed this assumption. Now come to the test of the normality. In the test of normality, Kolmogorov and Shapiro-Wilk test. Okay, here we compare the significance value. So according to statistician, if the p-value significance value is greater than 0.05, here 0.15 is greater than 0.05. So it means it passed the assumption of normality. Okay, same here for Shapiro-Wilk test. It is 0.08, okay, so it also greater than 0.05, so it's past the assumption of normality, so our data is normally distributed, okay. Now come again toward the SPSS file. So we will apply the one sample t-test because all the assumptions are passed, all the assumptions are like passed. Now we can analyze them. So come to analyze and come to compare mean, okay, compare mean, and then select compare mean one sample t-test, one sample t-test, okay. And now reset. So age, we want to compare age, the mean age, okay. So we select the age and we assume our hypothesis is the mean age is equal to 45. That I tell you in the presentation, the question of our hypothesis is like the null hypothesis is mean age is equal to 45, and alternate hypothesis is mean age is not equal to 45. So now let's assume that this is the sample and this is the population mean 45. So okay. So now SPSS will give you the all the test, the t-test, okay, the t-test table. This is just the normal statistics, so it is the sample size. So we have to check whether if there is any missing value, it will be shown some here, okay. So there is no missing value. Now come toward this test, okay. This is the main test, one sample t-test table. So here you come to the statistic, okay. You will see the p-value. So if the p-value in this case is greater than, or sorry, the p-value is less than 0.05, so we have to reject null hypothesis. And what was the null hypothesis? The null hypothesis was is equal to 45, but we reject because the p-value is less than 0.05, so we reject null hypothesis and accept alternate hypothesis. So the sample size, the sample mean is not equal to 45, okay. And you can also cross check it here, like to the in the description of like the sorry, this, okay, where you see the mean is 58.20. So the mean of the data is 58, but we assume that it is 45. So the null hypothesis is rejected and the alternate hypothesis is selected. So in this case our mean age is not equal to 45. So this is like everything about the SPSS. And you can also report it like this. Okay, if you want to report it, so you can report it like the average age of the sample is different from 45 years significantly. P-value p-value is less than 0.001. Okay, so if it is like, if here they mention 0.00, so you can mention it as, here the p-value is 0.00, so we can assume it is 0.0001. Okay, so this is like everything about the SPSS of like the practical demonstration of one sample t-test. So I hope you learn. If you have any questions, you can post them in the comment section, so I will try to answer it. Or if you have any problem in your research and you want to do the one sample t-test, so you can post the question in the comment section. Thank you so much. So if you are new to the channel, please subscribe, and so that you don't miss my upcoming video that I will cover each and every step of the parametric and non-parametric statistic. Okay, thank you so much, and hope to see you in the next video.